Good afternoon, everyone. Thank you for coming back. I would like to talk about my remote sensing and modeling approach for this flood response and management in Pakistan, and sort of share with you our experience as a case study of my work that I did when I was in Sparko, and introduce to you the UNESCO flood project in Pakistan that we're doing right now. And I've been a part of it through in UNESCO directly now, and before that I was in Sparko during the phase 1. So the slides in this talk are mainly going to be during that period. So, but it's all going to be in the same context. To introduce you disaster management in Pakistan, basically you can think of it as the country has a national level authority that works in operations and disaster risk reduction and in trainings, in National Institute for Trainings, and the provinces have their own disaster response agencies as well to respond and for the first aid and the entire operations that they do in the administrative process that come involved with it. But I'm going to talk to you about the spatial technology applications while sitting in a different organization, looking at the operations of the government and different bodies during the disaster stages and before disasters, and seeing how, from a perspective of a remote sensing and hydrology person, how we can aid with the spatial data sets these people and these organizations in the different stages of disaster management cycle. So effectively, the idea is to see what is the mandate of these bodies and organizations, and how do they basically work at different levels, starting from the local administration to the government levels, and how, at what type of spatial information in what form can help them improve their decisions or help them in their preparedness or a better response. So the idea behind this comes from what Dr. said. Okay, the availability of data in spatial data is not much of an issue these days. If you see, there's a lot of data access points, not only for open data sets, but also for high resolution spatial data sets or satellites. In Sparko, we had the access to the International Disaster Charter. You could just activate that, and any sensor would passing over the disaster area would get an imagery, and it would provide you for free of cost. And Sentinel Asia as well is an initiative that brings together a lot of sensors and a lot of space agencies from the Asian region, and the data sets made available free of cost for disaster, and sort of the UN Spider as a whole for the collaboration as well. So, but the entire background of this presentation basically comes back to the UNESCO flood project that Dr. I mentioned earlier today. In the phase 1 of this project, this project has been running on was initiated after mega flood of 2010 in Pakistan, and a lot of work was done in the phase 1 for flood hazard mapping on Indus River with the help of models developed at the ICHAM Japan with Indus IFAS and the rainfall inundation model. And while in that phase, the models were developed and calibrated by the ICHAM themselves, a lot of technical capability or capacity was built through trainings and through exchange programs within the project. Specifically for in the hazard mapping point of the phase 1 of this project, the 10, 20, 50, and 100-year return period floods were simulated using RRA model and a lot of base data that you need for damage assessment, may they be roads or agriculture area or infrastructure or urban area. All of that was mapped. So there was very within a certain buffer zone of the industry. So that was very helpful data and a lot of helpful information. So yeah, alongside that, there was some other information, ancillary information as well through other initiatives that were available to us. So for example, quality land cover through the GLCCS, the Global Land Cover Classification System. So not only the phase one, but phase one of the UNESCO project, there was a lot of data generated, but there were other data sets available as well for us to implement and see what helpful information we can generate for actually the disaster fighters on ground. So we, with the help of this model and the phase one's capacity that was built and that was transferred, we try to I'll send you I'll share with you a case study that we try to implement as a inundation forecasting tool, or sort of a forecasted inundation based damage assessment tool. So we use the rainfall runoff inundation model that's developed by ICHAM. It's Dr. Miyamoto is here. He can tell you a lot more on that, but it's just a distributed event-based physical model in terms of spatial temporal memory. So it can simulate rainfall runoff and inundation at the same time. It's one part of the whole project that has coupling of the two models. So we'll be in this particular application, we try to look at it as a standalone tool and see how we can really combine the a modeling exercise and get help from mapping from any source, any open data set or open or actually any other disaster data set that we can get our hands on from other sources by activating the International Disaster Charter or through Sentinel Asia or through UN Spiders hub. So can make that available to the mainstream disaster management stakeholders in the country. So yeah, we had the 2010 flood simulated during phase one, so we had the experience of a calibrated model on Indus River for inundation. We implemented the rainfall runoff inundation, or RRI, as a daily simulation tool to get the maximum inundation. And data sharing was brought into discussion. That's very important. That was a very important and difficult point to really get data real time from organizations that are custodian of the data, but there's no actual real open mechanism to get that access. So there has to be just like it was mentioned earlier, there has to be a director to director agreement kind of stuff, or handshake so that you get the data emailed to you every morning. That's one challenge that we faced, and we sort of foreseed beforehand, so sort of took care of it. But the mechanism was missing, and it's sort of still missing. So, and we developed a rainfall runoff application for other rivers that go into the Indus River as well. So first, I'm going to share a little bit about the modeling part. And that animation going over there is the 2010 flood simulation, if you've been wondering. So yeah, so we took the rainfall runoff inundation model and calibrate all the base calibrations that are required. We can talk about it in detail later on if you're interested. But what I wanted to share right now is that we, after playing around with it and trying to find a way, we got some really interesting results while using it as a daily inundation forecasting kind of a tool. We provided with 27 from the current day. We provided 27 days rainfall from the past and 27 days discharge data from the past from the current day, and then we let the model run for 30 days in the simulation. So that's actually a 1 month simulation period. So the simulation would kind of say the maximum inundation for 30 days, but the three days are in future. So you sort of get a maximum inundation that you would that it would occur in 30 days, as a 3 days, as a pseudo 3-day in forecasted inundation, spatial layer of forecasted inundation. So once we do that for 1 day, so when we come back tomorrow morning, we use the state of the model as it was, and then we input that in terms of boundary or initial condition as to start up, and then update 1 day's rainfall and 1 day's discharge, and run it again for the 30 days. So during the entire, because it's a huge basin and a huge river, the flood takes at least a month to the entire event of the flooding when it starts, and the entire hydrographic, it's 1 month or something like that, 20-25 days. So you can actually implement this type of exercise for the entire flooding season while it occurs. So that's sort of one animation over there. So the idea was to actually update daily a simulated flood depth map and the associated damages based on the data that we required previously, or the other data set that were in-house available with the agency through the other project, and mainly with the because of the phase 1 of the project, because that made a lot of infrastructure mapping that was done as well. So we would run the simulation for 30 days on the current date, and then we would upload this layer as a forecasted maximum inundation where the flood is going to go for the next 3 days. And at the same time, we would generate statistics and maps, because really the end users that we were targeting this time for this particular exercise in this type of application were not really learned in mapping and mapping tools and GIS analysis. So we developed statistics and printable maps as well for first responders or flood fighters or any people who are working on ground. So maps like this will give sort of the forecast, the damages that are coming in the next 3 days as a proxy of the damages that are coming in 3 days, while the layers uploaded can be accessed. And we developed a very basic tool with some basic ancillary tools in there to help you navigate where you are if you are on the field and that kind of stuff. Not really very fancy looking tool, but because we're not a web developing people anyway, we're doing it as an exercise, but it got really populated with data very quickly, so we never got the time to work on the statics until I left that. Anyway, so we generate the flood damages map for each administrative unit, or administrative unit by administrative unit, because of the complexity of the government organization, the working of the government organization, and how it translated down to the very smallest administrative unit in the country. You might just want to give them the most relevant information in the form that they understand, and not much. So we would generate maps and sets like this for every administrative unit and give and send them this information as what is coming your way. While in parallel, on the day, we would use a damage or rapid and a detailed damage assessment from any open data sets or through disaster charters or any high spatial or high temporal data sets that we get hands on. But before that, we would have already mapped the pre-monsoon type of or pre-flood event type of entire country water level layer. So we know where to correct our damages for. So where the river, this one particular is made from Landsat 8, 3 months mosaics. And then once we have that, we would use say Terra Modis or Aqua Modis for larger scale, and Landsat for higher spatial scale, Sentinel-2 recently for higher spatial scale, and then we make those stats and maps as actual rapid damages assessed or actual detailed damages if the data is acquired a few days um, after the date. And we distribute these maps as observed damages and along with the forecasted damages that are coming in the next 3 days in parallel. Plus, we do some fun with a Twitter account to tweet every layer uploaded or every map distributed, so that was helpful. And also through the Central Asia and the disaster charter, you would get Sentinel-1 scenes. You would develop a semi-automated type of water extraction or inundation extraction workflow that would work on the flat plains of Indus, because there's no spiky mountainous terrains anyway to get rid of it's pretty much flat, so you can have a simpler workflow to extract water. But then I'll translate that into a Google Earth Engine code. This is something that I think everybody who uses open datasets should be using for Landsat or for Sentinel-1 or 2 or that kind of sensors. If you don't know much about it, it's Google's initiative to provide access to data scientists or remote sensing people a web platform, a web-based JavaScripting-based platform to quickly analyze the data instead of downloading and getting their hands dirty with all the pre-processing and data downloading and handling that's required. There's nothing really required in here. It's a 40 years archive of all the Earth, open Earth observed data using MODIS and Landsat series and everything. You can simply, if I give a effective example, it would be just like calling the Earth Engine for a sensor name that would bring me Landsat 7 or 5 archive, filter it from 2000 to 2010, and then filter it on this polygon and how many scenes are there, and then you can quickly write an algorithm to come up with the analysis in less time, in a few seconds, instead of having somebody download all the data, the gigabytes and hundreds of gigabytes, and then doing all the handling all yourself. So it's actually the background data sets of Google Archive, but it's made available for you to put your code directly in contact with the data and get the analysis or analyze their output straight away instead of going the other way. So we sort of used to do the operational support based on the near real-time flood monitoring because of the near real-time availability of MODIS and the near real-time availability of the analysis capability of the Earth Engine. So if the data layer from Sentinel-1, for example, is made available by Sci-Hub, ESA, so Google Earth Engine, it would get synced to their servers in a couple of hours. So instead of downloading and searching for a scene on top of your area of observation, you can simply have a code saved to click run every couple of hours and see if there's anything new to give you a new water or a new inundation sort of layer. So based on that, we combined the hyperspectral, hypertemporal MODIS sort of imagery as a quick within an hour analysis and to be centrally distributed. But later we would add Landsat, SAR, Sentinel-1, and from other Sentinel, TerraSAR-X, LOS2, Pulsar, maybe RadarSat from InnoSat, from Central Asian as well, but not. But that was done in-house, not on the Sentinel-2. So yeah, because of this temporal look at. I should have put this back here because of this type of temporal daily forecasted 3-day forecasted damages and forecasted inundation as a moving window every day for the month. It really was really helpful for the government and government and other organizations that are working in the disaster. So it got integrated into the province, like Punjab province's flood relief portal. They actually made that to do a stock taking of what relief goods have been dispatched, how much people have been rescued, and all that kind of, how much livestock is damaged, how much livestock has been rescued, how many boats do they need. So they made a portal of that, and it got integrated into that and to the national disaster management portal. So really, the idea is if the information was really helpful to the first responders or the disaster management stakeholders at the level that they're working from, the if you look at the hierarchy of disaster management, it's really not really more the national crisis management. The head of the national crisis management is the prime minister anyway, but it's not really his job to be saving people's lives. It's the people who are working in rescues and flying boats and that kind. So this kind of tool, very basic looking, but having all the forecast inundation for the next 3 days and a basic find my location tool to be able to open in their boat or on their chopper or whatever, and the damages that have come until today and the damages that they can foresee for the next few days. It got really, so it sort of got became the first go-to at every control room. And that became at that point it became serious for us to think about how good it looks or what tools we can add or what are really essential, because we, not being a WebJS guy, just made it on my machine and then we started to play around. We just tried to experiment how, if this information put into the open in this form, in an understandable form, along with the printed and even most of the times tables of areas of damages or crop damages for people who are not very literate or having access to their own local administrative area. So how would this information respond? It's sort of exploded. But effectively, the platform itself, Disaster Watch, is not really complicated. Simply all open, based on open technology. QGIS Web Client 1, a geo server at the back for the raster layers, the simulated ones and the ones that we would generate from satellite datasets. Vector database was in PostgreSQL, so it would easily do some stats and extractions from the vector database, and an automatic map book generator for district level or administrative unit level damage assessment map making tool in some analysis. So I think, what's the time? Yep, I think that'll be enough. Thank you very much.